Okay, let's see today's question. So in the question you are given in 2D array, every element contains three things: start time, end time, and value. So basically, it specifies that at which time. Start time specifies that at which time the event is starting, and end time specifies at which time the event is ending, and the value specifies that how much amount of uh, value you are earning after attending that event. Okay, and at most you can attend uh, only two events, okay, which are non-overlapping. What does non-overlapping means? Non-overlapping means like if you attend an event like event zero, so it's starting at 1 and ending at 2. Okay, so ending at 3. So you can only event the event which is starting at greater than 3, starting at time greater than 3. So you can only attend this event. You can't attend this event as the starting time of this event is less than the ending time of this event. So you have to choose at most two events, okay, which are non-overlapping, and you have to maximize the value. Like if you attend two events, you will get two values from both the events. Okay, and but yeah, those events should be non-overlapping, and you have to find like what is the maximum value you can achieve by at most attending two non-overlapping events. So what would be the approach for this question is uh, we can sort first of all the array based on the starting time. Okay, so why we're doing it? So uh, let's try to think brute force. Like what we'll do, we will take this event, like we will try that we will first attend event 0. Okay, and then we will see all the events which are greater than the end time of the event 0, which is 3. We will consider all those events, and we will select that element which has the maximum value from it. Okay, so, but if you do this, you have to you will take n square. Okay, and the n is 10 raised to 5, so 10 raised to 5, so it will not work. So you have to come up with a solution which is something like n log n or big of n. So big of n, I am not getting in this, but yeah, n log n, what you can do, you can just sort the array. Okay, now you are sorted with the sorted with the start time. Now you will let's suppose you select this event. Okay, now you this ending time of this event is 3. Okay, so you have to select all the you can have to choose between all the events which is whose starting time is greater than 3. So basically greater than equal to 4. So you will the array is sorted, so you will just traverse it, you will just binary search uh, based on the starting time, and you will get all the elements which are great. Like you will get the index of the minimum element which is uh, like minimum starting time element which is greater than equal to greater than 3. Okay, so you will get that, and but you have to now store here that what is the maximum of those elements. So like in this example, if you can see is yes, uh, not this, wait, 1 5. Okay, let's take this. So uh, the ending time, let's suppose we choose this event. Okay, now the ending time is 3. Okay, so you have to select all the events which are greater than 3. So you will starting time greater than 3, so you will select this element. Okay, and you can't select this. So the binary search will give you the index of that element which is in the sorted form, and now you will uh, consider all those elements which are greater than that. Okay, so if 4, like let's suppose there is an element in this, one more element which is 5 7 and 5. So now 5, it's starting at 5 which is greater than 3, and its value is also 5, so which is greater than 2. So you will consider that one. Okay, so you will consider all the elements which are greater than, like which are after 4, because it is in sorted fashion. Okay, and now you have to keep the track of maximum, which is the maximum element, uh, maximum value of element from the till the ith index, from like from I to last index, which is the maximum. So you can just make an array max and do that. So first I will do that. First I will sort the array. events based on first. Okay, this will sort the events array based on the starting index. Now I will uh, pre-compute the max array. Okay, so I will keep on 0. I will traverse from last as I want to mm, get the, like, if I am want to get the maximum element from I to n, so I have to traverse from last to track maximum. I is greater than this, I minus minus. Okay, so max of I is equal to max dot maximum of events of I comma 2 m, and m is equal to max of I. Okay, so you have pre-computed that. Now for every, like, index, like, you can select anything now at first. So for every, let's suppose select the first index, first event. So current value will, what will be the value? Of events of I comma 2. Yes, and let's initialize here a variable uh, telling that what is the maximum we have received value till now. Yeah, now what you will do, you will get the index of the element which is just greater than the end time of the current event which you have selected. So you will, how you will do that? Binary search events of yeah, you have to find the smallest index which is greater than n time of current selected event. Yeah, so I 1 plus 1. Okay, so now if this index is returning minus 1, that if there is no element present, like that, so you have to then, now you have the option only to select the only like, you have to select at most two, so you can also select only one. So you will select only current, and what you will do, if it is not equal to minus 1 actually, so current is equal to current plus yeah, max of id which we have pre-computed. And yeah, you have to update answer now, dot maximum of answer comma current. Now let's write the code for the binary search for this. Okay, so public int yes int events, int x is the any time which we are allowed. We have to find the minimum starting time which you are allowed. Okay, so uh, start will be 0 and will be events dot length minus 1. And let's assume that we don't get an answer for starting at start, and we will update it in the binary search while x is less than equal to e. Okay, so calculate the mid. Okay, now if events of I comma 0, not I actually, mid comma 0, if this is greater than equal to x, so yes, this can be a possible solution. This can be the minimum element, but we are not sure. So we will mark it as mid, but we are not sure, therefore we will do this thing for the elements which are lesser than this, starting index lesser than this. So um, end is equal to mid minus 1. We'll just shorten the range, else we will just do like start is equal to mid plus we will, if it is smaller than x, then obviously we are not getting it in left, so we will get it in the right thing. Okay, so this is for left and this is for right. Okay, and at last we will return answer, the index. Okay, let's run this and submit it. Yes, it's getting accepted. Okay, thank you for watching.